I'm here. Thanks. Good morning. Morning, everybody. Today we're going to have a slightly different tech talk. Normally we come out here, we quote the standards, and we tell you where to fit what and how to do your installations or how to assist. This morning's tech talk is going to be about pointing out pitfalls and loopholes and making sure that we don't get caught. The majority of us would be licensed plumbers signing COCs. So when it comes to geysers in series, let's have a look at what and why and what we need to look out for. Multiple water heater installations are predominantly used in commercial or industrial applications where a high volume of heated water may be required during peak hours, or where insufficient planning was done to supply hot water to a new build in order to comply with XA2. So if we have a 3-bedroom house and we need 300 liters, we're looking at a geyser that needs to be fitted somewhere, or that's always an afterthought. So when we get to multiple connections, there are two main methods of interconnecting these multiple hot water cylinders: series connection and parallel connection. So this morning we're going to look at series connection, and it is pretty much like you were taught in primary school with those little AA batteries where the negative joins onto the positive and you form like a little train. The same thing happens with hot water cylinders. Cold water gets fed through each tank, one after the other, with the hot water outlet from the first tank. So, sorry, let me just get my hand out. Yeah, I am like that. Here we go. The cold water in, and the hot water outlet from the first tank will become the cold water supply to the next tank. And then that little train carries on until we get to the last one. Sounds simple enough. The only issue, or the biggest issue at this stage, is that when we look at the one document that governs installation, maintenance, replacement, and repair of fixed electric storage water heating systems, we will find that if you look at the scope of the document itself covers the safe installation of new and replacement fixed water heaters, complete with the relevant and applicable safety and hydraulic control units, and then it goes through the whole rigmarole of what it does. I would like to draw your attention to this portion in the red outline. This standard does not cover sizing or hydraulic design of the storage water heating system. In other words, it is simple off the shelf onto your client's premises. The standard does not cover the design and installation of industrial hot water systems either. Then that's just the kickoff. That's the scope of the document. Then this caption or this slide then shows you what 10254 is all about. But if we go into the installation bit, obviously the first thing that it says is that all the components will be of the approved type and it shall be matched in terms of pressure rating. We all know that. 4112 says, where some of the provisions of this standard cannot be applied, the installation shall comply with the details given in a rational design designed by a professional engineer on acceptable installation drawings. In other words, not his word for it, or he made a sketch on the wall before the painter came along, an installation drawing that you can refer back to. And such rational design shall not compromise the safety and the performance principles incorporated in the standard. In other words, equal or better. The reason for this morning's tech talk. 4114 says, on completion of the installation, a certificate of compliance from the professional body for plumbers registered in terms of the relevant national legislation, and if you look at the forward, you'll see in this case it's the Plumbing Industry Registration Board, shall be issued to the owner of the installation or to the body requiring such a certificate. So when you see something that is outside of the scope of this document, there should be red lights and flags going off all over. You don't have to walk away from it. You just need to make sure that you get something on it and on a layout, even if it's from the manufacturer. But from the manufacturer side, I can tell you I've seen some vicious ones that don't even incorporate basic safety. So even if the manufacturer gives you a layout of how you're supposed to connect these things, make sure that it complies, or make sure that you're happy with what you see on that drawing. You're looking, I put little notes here for each unit, for each unit, for each unit. We're working on the understanding that when you're putting a main shut-off control, it shall, or ease of maintenance, the inlet pipe to a pressure control valve or a float valve, but not applicable for this morning, shall be furnished with an isolating valve. You're looking at vacuum control valves. It says enclosed and valve operated system. Vacuum control valves shall be installed on hot and cold pipes to and from the water heater to ensure that both lines and the heater, take note, not only the cylinder, but both those water lines as well as the heater is protected against siphonage. Once again, I'm going to refer to each unit. Expansion control valve and on the cold water supply, and it says when an expansion control is installed on that cold water side of the water heater, it shall be installed downstream of any isolating valve, gate valve, non-return valve, or any other flow control device. So in other words, each unit, I say unit, each cylinder, each installation should have the minimum of these fittings on top of your TP valve, all of the rest of the details that are applicable to a normal 10254 installation, or any Geyser installation for that matter. So when you look at this here, and I'll take you to SANS 10.10.6, this thing refers to a preheater system. So you'll find that that cold water used to go through the control valve or the shuttle valve and the pressure control straight into the old electric pre-existing hot water cylinder, and then there's an interruption by adding a 10.10.6 compliant system, then pre-feeding that. So you have solar water heater preheating this water in the cylinder here. Take note of the system bit, and then you read the note, and it says solar preheat, and I just repeated the little detail here while we're talking. There will be no continual circulation of hot potable water between the solar water heating system and the pre-existing electric storage water heater. In other words, that system, that solar system, is going to work by itself, collector, cylinder, and this would heat up the water to the point. The cold inlet to the solar preheater is connected downstream of the existing pressure control. In other words, pressure control first, then you get your solar, and the hot outlet of the solar preheater is connected to the inlet of the existing electric storage heat, not into the hot pipe. Flow or solar water heated to the pre-existing electrical heater only occurs when water is drawn off at the terminal fittings downstream from that supply, and this option may negatively affect flow pressure performance at terminal fittings due to additional inline friction pressure losses. So that's the theory. Let's have a look at a typical layout. Guys, this is not a design. Take note, I'm a licensed plumber. I'm not an engineer. I'm just saying that as far as general practice is concerned and the way or the requirements put together for a series connection, this would be a typical layout. You'll have your cold water coming into the line, and cold will become hot. Hot would go back into the cold side, and hot would come back and into the cold side, and hot would come back into the, and then it'll exit to wherever you are proposing on working. Looking at the system, it's straightforward enough. There's a couple of extra valves you would have noticed on the top. You'll see they're always closed. That portion would be considered your bypass to that last always closed valve. So when you look at that system, there's a couple of things amiss here, and this is where the guys that are awake and the guys that are actually looking at the standards will tell you that if there's a valve between the geyser and the pressure control valve, you will require additional expansion relief on that system. It's not optional. Remember, we looked at those three sections now. There's a shutoff between the vacuum breakers and the cylinders. I don't have vacuum breakers drawn in here for simplicity. We'll have a look at that later. But you can't have a shutoff between a vacuum breaker and the cylinder, or the pipe for that matter, but we're looking at vacuum breakers per cylinder. When we're looking at the energy efficiency in terms of 10400XA, there's no 50% of anything. At this stage, we're looking at merely having electrical supply to each of those cylinders without any energy efficiency. And then when we look at the arrangement of pipework, like I said, this is 2D. There's no ways I can draw all of these pipes and indicate all the vacuum breakers and all the other pipes in there. This is just a schematic. Take note, non-residential. Now this here would be the way to actually look at the installation. For the guys old enough, if you recall, you used to get these Christmas lights that if you bought a string of Christmas lights, you put them on the tree, one of those little bulbs blew, the whole thing was down. This is what we're trying to avoid with the system. If you are adding or you're connecting in series or parallel for that matter, a number of units, that would be to increase the volume. So if one of these cylinders had to go, what you do is you'll still have your cold water coming in. Out on the hot water side, now you've closed the in and out to that faulty geyser, so you've removed that. You open the bypass, the water would go through that bypass, down into the cold again, and it'll continue running as before while you're replacing this one. That's the theory when you're looking at series connection. That's why you have these additional valves in there, and that's why you have the system the way it's shown here. So what happens now is that when you're looking at these cylinders, or you get into a position where you are requested to do a series connection, there's a couple of things you need to bear in mind. The system operates pretty well under low or peak demand, so it does not affect your actual supply. A bypass must be installed so that any faulty tank can be replaced without interruption of flow, as per the previous slide. If something goes wrong with one or two of those cylinders, you actually just open the bypass, close the hot and cold supply, or close those two valves on the hot and cold supply, and the system runs while you're doing the maintenance on the rest of it. Different types of cylinders may be used, but the one with the highest kilowatt rating must be first in line. So the one that heats up the water fastest and best starts heating up the water, and you go through the system as you go along. Pipe sizing on the system is limited by the inlet and outlet of the cylinder, so you'll always be working in 3/4, maybe up at 1 for 2 geysers into maybe a 1-inch pipe or something, but the sizing or the starting off point from those cylinders are always going to be governed by the inlet and outlet on the cylinders. While we're looking at those cylinders, then you also start looking at dead legs, but we'll come back to dead legs just now. I don't want to preempt the thing. If you consider cumulative pressure drop through each unit, let me just get back. Okay, let me explain that in the following way. When a geyser or hot water cylinder gets tested by whichever body somewhere, pressure drops through these it's not part of their testing regime. I mean, don't go and find that one geyser loses X amount through the inlet and outlet system or in and out line. Those diffusers that they require, or the diffuser that is necessary at the bottom of the inlet of these cylinders, they vary from pipes with little slots and holes into them to a T-piece that spreads to the side. Some of them have bigger boxes in there. So these things vary from manufacturer to manufacturer, but there is a definite pressure drop through that restrictor or through that diverter, if you want to call it that, down the bottom of the inlet. So if you're saying a cumulative pressure drop, if you have 3 or 4 of those restrictors in the same line on the same supply, they will get to, or they will amount to something by the time the water gets out to the other. So when you start adding these pressure drops together, you start battling to get your balance pressure sorted, not necessarily pressure, but also volume and flow rates. So all of those things need to be incorporated into, if your client's going to want to run those 4 cylinders with 30 geysers or 30 showers at the end of a shift or whatever they need the water for, then you need to look at the sizing and you need to look at what is available. The next point, something that we've dealt with numerous occasions, from the new installations to the insurance bit. SANS 10142 requires an isolator per geyser. Now, if you have 4 geysers in the roof or 4 geysers in an installation instead of 1, immediately the first thing that's going to happen is you're going to have to start increasing wire thickness, because I think the electrician I spoke to yesterday was adamant that if you go from 1 geyser to 2, you'll probably have to go from 2.5 wire to 4 millimeter. So you need to increase wire size, And then the moment you get to the third and fourth geyser, you might have to get that thing wired right back to the DB to make sure that the breaker doesn't get overloaded, or you don't have a breaker in there that's bigger than the actual supply. So it becomes more complicated from the electrical side, but strictly speaking, it doesn't affect plumbers, or it doesn't affect us, but it's something that you need to consider, that if you're doing a replacement and you notice that these things are basically the same size as any other geyser, there might be some wires heating up, or there might be some issues. Better refer to a qualified electrician and let him sort it out. The next thing, being a non-deemed to satisfy, being a design, in other words, something that was put together specifically or case specifically for that installation. The safety requirements, when I say safety requirements, that would be from a number of documents. Health and Safety, Consumer Protection Act, you can all throw all the big guns in there. But as far as the plumber is concerned, every valve that you install on that system needs to be labeled. This will be the cold water supply to Unit A, Unit B, Unit C, Unit D. And you need to supply the client or the managing agent or the maintenance guy on that installation with operating instructions, so that when someone not familiar with the system, or someone that did not do the installation, walks into that room and they see there's 12 valves on 4 geysers, that they don't start opening and shutting valves, or opening a bypass so that it skips a geyser altogether. You need to give a clear operating instruction on how the system is to be operated or maintained, and then relevant warning signs to be installed. So there should be notices up which ones you may or may not close, or in the case of failure and you walk into the room and there was a burst, 2 or 3 of them burst, which one is supposed to be shut off to shut the whole system down. You need to be very clear when you leave that room, that if you're not the one doing the maintenance on it, the next person that walks in there, I think it's only fair plumber to plumber, the next guy that walks in there looks at the system, you can look at this diagram and say, okay, this is what's happening here, this is where the flow is, I can cut this or I can move this. It all becomes a lot clearer. Then, like I said earlier, most new electrical only geyser installations will not comply with XA2 from the building regs. So unless it's an out and out industrial application where they don't have a hassle with electricity consumption, you cannot have electrical only supply on a new installation. So if you are given a diagram with only electric geysers for a H4 residence, then already there should be some flags going up saying you need to find out what is going to happen with the alternate source. We've all seen this, we've all negotiated around this, we've seen plenty tech talks about roof reinforcement. Richard's done it, Marius has done it, there's been a number of presentations around this. I would like to just highlight something from having looked at this detail. There's one that runs perpendicular to the trusses, and there's another detail that runs parallel to the trusses. But at the bottom of that, there is a note. This says geyser supports up to 150 liters, supported on trusses not exceeding 8 meter span. And then the red highlighted bit says only one geyser allowed per 3 trusses. In other words, when you're putting a geyser in, you can't have a geyser and then they share a truss before you stagger this one and you go back. You can't, there's 3 trusses per geyser, and that is the maximum load you can put on there with a geyser. To clarify that even more, if you're going to look at this system here, you've got 760s between, or 760 centers between the roof trusses. So the comment from the previous slide, then if you are going to be using 3 geyser or 3 trusses per geyser, that would be a compliant installation on its own. But if you now start adding these 4 together, it gets a bit more complicated, because all of a sudden you're looking at around 8.5 meters of pipe work, excluding the anti-siphon loops from where the cold water comes in, passes through the whole system and exits on the other side. You can see there's like 1 meter sections between outlet on the hot side to the cold on the other side. So 8.5 meters before you even have hot water leaving the cylinder. So the note on the top says that these installations require placement that will in turn require longer pipe work between cylinders. Any plumber that's ever fitted a geyser in a new build or a house or replacement, you do realize, or you are more than aware, that there's hardly ever space to work in there. So you can imagine if you had to do 4 geyser installations in one roof and still get them to comply and interconnect them all so that they end up serving or being able to serve up 600 liters instead of 150. You can imagine the nightmare of putting that together in someone's residential roof. This is my closing statement. I'd like for you to think about this. In terms of geyser installations, be careful when signing off on these types of installations that may or may not be compliant. I'm not saying all series connections are non-compliant. I'm just saying that make sure that they are compliant. Series connections of hot water cylinders are not covered by SANS 10254 of 2017. Each installation will be unique with different layouts, flow rates, space for working, demand from the building occupants. And if you recall the tech talk we did around rational designs, if a rational design was done, you will find that you'll be signing off your workmanship and the material. And the guy that did the design and was responsible for that design would then actually sign off his design or the actual extra over from the standard will be done by the guy that did the design. Like so I said, no drawings on the wall, none of those. It's simple. The guy gives you a drawing that you keep as a reference. It was done according to his drawing 100%. So you're covered by his design. He signs his design, you sign your workmanship. So like I said, today wasn't a how to do it. We're looking at how not to do it or what to look out for. Have we got any questions?
All right, we do in fact have a couple of questions here for you. The first one reads, can you fit a shutoff on a HW after a vacuum breaker?
After a vacuum breaker, yes, but not between the vacuum breaker and the cylinder. In about 4 places, including SANS 10252 water installations, that says you can't have a shutoff or a flow control between a vacuum breaker and a cylinder.
All right, the next question reads, if 250 liters are plumbed in series hanging on a wall, or 2 separate 150 liter geysers next to each other like they do on blocks of flats, is this compliant? As per SANS, a geyser bigger than 200 liters is not allowed to be hung on a wall.
There are two sections to that question, if I understand it correctly. If you are plumbing them separately, there should be no problem with that at all. It's actually compliant with SANS 10254, but if you're saying mounting 250s next to each other, that's not a problem. But the statement at the end of the question referring to the 200 liters or bigger than 200 liters, you cannot also wall mount those. That's also 100% correct. That's if I understood the question properly now.
Right, the next question reads, would you still be required to install an expansion relief valve on each geyser in series, especially if they've got isolating valves in between each cylinder?
Yes, you will. The requirement is that, let me just find that slide here quickly. The requirement from that is that an expansion control valve is installed on the cold water side of the heater. It shall be installed downstream of any isolating valve, gate valve, non-return valve, or other flow control device. So that requirement is always going to be there. If you do have a shutoff valve between your original pressure control valve where the line starts and the actual cylinder, any installation or any shutoff valve between that pressure control valve and the cylinder, you will need downstream of that isolating valve. In other words, between that isolating valve and the cylinder, you still need to have your pressure control. I mean your expansion control.
All right, perfect. And then the last question I have got at the moment reads, who is the guy you speak of to sign off the design of a geyser in series? Is it the architect?
Definitely not. Please, definitely not. The definition, if you look at 10254, the definition of a competent person would be an engineer. I've seen it happen before. I would approach your geyser manufacturer. I've seen some horrible designs, but there are one or two that are actually workable with a little bit of a change here and there. I would start with them and ask them as manufacturer if they would be happy with this, and then they can supply you with a layout. I'm not saying that layout's necessarily going to be correct. We have sent about 3 or 4 back to the geyser manufacturers because their designs are slightly dodgy. But the theory is that you need a competent person, as per 10254 would probably be like a wet services engineer or someone that has got experience with regards to flow rates and equal or better than the standard. That's where it starts. So I would start with the manufacturer and say, look, if they can't give you a design to go around that, maybe they can refer you to someone. But please, no architects. I spoke to the guy at our local university. They say they spend in a 4-year cycle in training architects, they spend about 2 days on water and drainage. So I wouldn't take advice from someone like that.
All right, we've had another question come up. It reads, is there a siphon loop required between cylinder?
Yes, on each of them. That's why I said on that diagram I did, there's a 2D, that one. This is 2D. The requirement is that if you are going to be, as per the vacuum breakers, each of these cylinders must have it's a complete entity on its own. So if you did one geyser properly, in anti-siphon loop, out anti-siphon loop, all the controls on that, you repeat that times 4. So you most definitely need a anti-siphon loop on that.
Right, 100%. And then we've just got a comment here that reads, always follow manufacturer's instructions and specifications in terms of wall hanging. Check the serial plate if it looks and hanging a 200-liter geyser if it's designed for the purpose.
Yes.
All right, 100%. But that's all of the comments we have got here at the moment. Adrian, would you like to go ahead and end off?
Yes, guys, next week we're going to have a similar look at parallel installations. Please bear in mind that I said when I started off, this was not how to do it. This is what you look out for before you put your signature as a licensed plumber on a document that says, I certify that the material and the installation and all the rest complies with standards and bylaws, and that don't take that responsibility. That job gets audited, something's wrong, or there's a safety issue somewhere, you will be required to repair or bring up to spec that whole installation. So if it becomes awkward or it looks funny, or when you look at it as a licensed or qualified plumber, you look at the installation and it looks different, or it looks I don't want to say dodgy because not all of them look dodgy, but the point is that if you're looking at the installation and it doesn't feel right, rather double check before you do it. Take care of yourself, guys. Keep it safe. Chat to you next week, Thursday.